Okay, so we are continuing on with trigonometric functions, and today we're going to be looking more closely at the unit circle. So if you remember what we did before, we looked at the 6 trigonometric functions. So if we have a central angle theta, we have the sine of theta, the cosine of theta, the tangent of theta, cosecant of theta, secant of theta, and the cotangent of theta. You probably remember SOHCAHTOA, so we know that sine is opposite over hypotenuse, etc., and so on. What we're going to be looking at are different interpretations of these values. And so we start by recognizing this. So this is our unit circle. And here what we did was we have a line going from the center of the circle out to the actual circle, out to the edge of this circle. Then we dropped a line straight down to the x-axis. So this line right here, this is the vertical distance. With any graph, with any point on a coordinate plane, this vertical distance, look, if I do my best to draw a straight line here, that's always the y value. So this right here, this is the y. Now we've looked at before, if this is our reference angle, then this is also the opposite side. So where we have the opposite side, we actually have y. So here sine of theta is the opposite over hypotenuse. Well, that's just y over the hypotenuse. The adjacent side is this horizontal distance. Well, if we go from 0 to some distance out on the x-axis, that's just our x value. So this adjacent side is x over the hypotenuse. Now hopefully you remember that the radius for this unit circle we actually said was 1. So the radius is 1. Well, notice that the hypotenuse for this triangle goes from the center out to the edge. That's the definition of radius. So this hypotenuse is equal to 1, which is also the radius. So that means that the sine here is just y over 1, or y. The cosine is x. So the sine is the y value, the cosine is the x value. Remembering the reciprocal nature, the cosecant would be 1 over y, and the secant would be 1 over x. So what about tangent and cotangent? Well, we could work out some nasty fractions here. So tangent would be the opposite, which would be y over 1. And then the adjacent would be x. So tangent would be y over x. Whoops, getting ahead of myself. Tangent would be y over x. Cotangent would be the reciprocal, which would be x over y. So these are our new definitions for the trig functions. So that SOHCAHTOA stuff, that's when you have just a basic triangle. But when we're dealing with the unit circle, we look at sine to be 1, cosine to be x, and tangent to be the difference, or sorry, the quotient between the two, y divided by x. So what we're going to do now is we are going to look at all the angles and then take a look at the triangles. So this is the unit circle. So previously what we did was we looked at all these different angles. So this right here, we said that this was pi over 3, pi over 4, or sorry, this was, I made the mistake I was just going to tell you about. This is pi over 6, this is pi over 3. We want to be careful that we realize that pi over 3 is up here and pi over 6 is down here. This is pi over 2. And if you remember what we did previously, we basically just count it by the pi over 6. So this is 1 pi over 6. This is 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. Then we have 5 pi over 6. 6 pi over 6, which is just pi. 7 pi over 6. 8 pi over 6, which we reduce to 4 pi over 3. Then we have 9 pi over 6, which we reduce to 3 pi over 2. Then we have 10 pi over 6, which we reduce to 5 pi over 3. And then we have 11 pi over 6 that we can't reduce, and it's just 11 pi over 6. And then 12 pi over 6, which is 2 pi. Okay. So those are the values there. And then these solid lines are just the quarters. So pi over 4, 2 pi over 4, which again is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, 8 pi over 4, which is 2 pi. So this is what we previously did to find the angles for radian measure. Now, if you remember what the degrees were, pi over 6 is 30, and pi over 3 is 60, and pi over 4 is 45. So if you ever wonder why we look at those angles that we do, well, because with this triangle here, we make close to a 30, 60, 90 right triangle. This is important because what we're going to be doing is we are going to be looking where these points are on the coordinate plane. So the radius is 1. So if this is 0 to 1, the y value doesn't change. So this point right here is just 1, 0. If we go in the negative direction for pi, it's negative 1, 0. If we go straight up, we get 0, 1. And if we go straight down, we get 0, negative 1. Well, what about this 30, 60, 90 triangle? Well, this is actually where our geometry comes into play because we have those special right triangles. So if we think about a 30, 60, 90 right triangle, here's our 30-degree angle. We know that the hypotenuse is the radius, which is 1. So for a 30, 60, 90 right triangle, the hypotenuse is always 2 times x. Well, if we know this distance to be 1, then we can say that x is equal to 1/2. So that means that this distance here, this opposite side, is equal to 1/2, and this adjacent side is equal to 1/2 times the square root of 3, or the square root of 3 over 2. I just said the adjacent side. Well, what did we say the adjacent side was previously? We said the adjacent side is the x value, the x coordinate. So here, this 30-degree angle, this adjacent side is the x distance. That's the x coordinate, root 3 over 2. The y coordinate is the opposite side, and that's a distance of 1/2. So that's why this point right here is root 3 over 2, comma, 1/2. We can do the same thing for pi over 3, except now this is our 60-degree angle, and this is our 30-degree angle. So across using 60 as our reference angle, the adjacent side is now 1/2. So our x-coordinate is now 1/2, and the opposite side is our y value, which is root 3 over 2. So notice they switch. Now for pi over 4, don't forget that's a 45-degree angle. So here, we already know that this hypotenuse is the radius, which is equal to 1. So we get that x is equal to 1 over the square root of 2. So we multiply this by square root of 2 over 2 because we need to rationalize the denominator. So that's root 2 over 2. So that means that x is root 2 over 2. So this is root 2 over 2, but notice with a 45, 45, 90 right triangle, the two legs of the right triangle are the same. So it's root 2 over root 2. So in this first quadrant, we have these values for these points. Now, there is a very, very special pattern because if we wanted to memorize this whole unit circle, certainly trying to reconstruct special right triangles each time would be very, very difficult. So instead, what we do is we realize there's a certain pattern. First off, notice all the denominators here are 2. So that's easy enough. So all these points here are going to be fractions that have denominators of 2. And for 5 pi over 6, even though we're talking about this large obtuse angle, we're only still using this as our 30-degree angle, which is our reference angle. So what we're going to do now is we're going to go across, but look at the x values. Root 3 over 2, root 2 over 2, 1/2. 0. 3, 2, 1, 0. So going down, as we continue into the second quadrant, these x values are going to go the same way. So 3, 2, 1, 0. 1, 2, 3. The y-coordinates go 1, 2, 3, 0. So they are going to go 3, 2, 1. 1, 2, 3, 1, 3, 2, 1. Now, we have to be careful, though, because now we're in quadrant 2. Because in quadrant 2, all of the x values are negative. So what we want to do is we just want to make sure we plop a negative sign in front of all these points. And then we continue down into the third quadrant. So we're looking at these points here. Running out of room. 1, 2, 3 for the x values. So we go 3, 2, 1. The y values go 3, 2, 1. So the x values, or sorry, the y values here go 1, 2, 3. But because we're in quadrant 2, both the x value and the y value are negative. So we get negative, 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 negative. And then into the fourth quadrant, we go 3, 2, 1, and then we go 1, 2, 3. The y values go 1, 2, 3. So now we are going to go 3, 2, 1. Now because we're in quadrant 4, the x values are positive again, but the y values are still negative. So these all get negative values. And so now you can kind of see, just looking at this, it looks overwhelming. But we found all the coordinates just off that silly little pattern. Look at the x's. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. As long as you remember this pattern and the correct sign for which quadrant you're in, then you'll be able to get any problems where you have to evaluate the trigonometric functions. So here are some examples of some problems. So this first one, we want to find the sine of 5 pi over 4. Well, remembering back to this, that the sine is the y value, on the unit circle, 5 pi over 4 is right here. Well, what is the y value? It's root 2 over 2. Negative root 2 over 2. So we get negative root 2 over 2. That's it. There's no math involved for these. It's just a reference of the unit circle. So you need to make sure that in order to answer any of these questions, you need to understand the unit circle. So next up we have cosine of pi over 4. The cosine is the x value. So pi over 4 is right here, and the x value is root 2 over 2. So we get positive root 2 over 2. That's it. Tangent of 0, well, that's a tricky one, but it's right here. 0 is the same as 2 pi, don't forget that. And so the tangent is y divided by x. So we have y, which is 0, divided by x, which is 1, and that's just 0. Cosecant is 1 over the sine. So for 2 pi over 3, we find the y value, which is the sine, which is root 3 over 2, and we do the reciprocal of that. So 1 over root 3 over 2. Well, the reciprocal is just going to be 2 over root 3, but we don't like to have this irrational number in the denominator, so we rationalize this as 2 root 3 over 3. Secant is the reciprocal of cosine, so 5 pi over 6, for the cosine we'd be looking for the x value, which is negative root 3 over 2. For the secant, we're looking at the reciprocal, which is negative root 3 over 2. So we get negative 2 over the square root of 3, which again we rationalize the denominator to get negative 2 root 3 over 3. And then finally, for 7 pi over 6, if we want to find the cotangent, cotangent is x divided by y. So cotangent is going to be negative root 3 over 2 divided by negative 1/2, x divided by y. Well, division is the same as multiplication of the reciprocal. So negative root 3 over 2 times negative 2 over 1, and this is where knowing how to multiply fractions comes in handy, because these just cancel out. Negative times a negative is a positive, so that's just the square root of 3. And that's it. What we're going to have to do, you're going to have a whole bunch of questions like this, and you need to remember this. Now, like I've explained with the pattern, if you know the pattern, you don't have to worry about committing this to memory. However, if you are able to either reconstruct this or know this, then you are able to answer these questions. But there's no math involved with these types of questions other than knowing this unit circle. So what I would recommend is try to reconstruct this from memory just to see if you understand the pattern and the relationship between all these angles and all these points in the unit circle.